Let's start with example number 1. Okay, so for example number 1, so we are given a prime notation for the differentials. X, y, y primes equals to 1 plus y squared. Okay, so for uniformity, so we can transform y prime into dy over dx. So we can clearly see so which variables or functions are multiplied with dy, so which are multiplied with dx. Then is equals to 1 plus y squared. And then so we separate y from x, so therefore we multiply the entire equation by dx, and thus giving us xy dy, and then that would be equal to, so 1 plus y squared is multiplied it with dx. And since our objective here is at the left hand side, so we remove all x. So to remove all x, so we multiply it by the reciprocal. So reciprocal of x would be 1 over x. And then since 1 plus y squared is multiplied it with dx, so that should be the one that we're going to transform at the or to the left hand side of the equation. So thus we multiply it with its reciprocal as 1 plus y squared. So doing so the left hand side, so x will be cancelled out, so leaving us to have y all over 1 plus y squared, and then multiplied it with dy, and then it is equal to, so for the dx, so 1 plus y squared will be cancelled out at the right hand side, so leaving us to have dx over x, or 1 over x, and multiplied it with dx. So in here, so this is the methods for separable equation. So all of the y's that are at the left hand side, all of the x are at the right hand side. So next is once we separated y, so from x, so we do the integration. So now, so we can see here as rational functions of y and a rational function of x. So recall that if we derive the denominator and we'll be able to arrive to the numerator, then that will be a logarithmic function. So in this case, our u here will be the denominator, which is 1 plus y squared. Then our du will be, so derivative of 1 is 0, derivative of y squared will be 2y. Then of course, do not forget the dy. But then, so remember that the numerator is this, so y dy. So we have y dy there, but we are in excess of 2. Okay, so in comparison to the given, so thus we neutralize it. Okay, so we have a neutralizing factor, which is 1/2. And then for the right hand side, if we let u as x, and then du, so derivative of x, it's dx. So as we can see here, so this is the same. So 1 times dx is dx. So thus the denominator can be, or the derivative of the denominator is the numerator as well. And that's the formula that we will be using. Okay, so for both cases, so will be a logarithm. So remember that du over u, okay, so I can write it down that the integral of 1 over u du, that is the same as ln u plus c. Okay, so that is our formula. And thus, y then will be, so we start with the neutralizing factor of 1/2, then ln of 1 plus y squared, and then that will be equal to dx over x, that would be ln u, or that is ln x. Then of course our arbitrary constant c. And since there are two logarithmic functions, so we can combine them both at the left-hand side of the equation. So giving us 1/2. So ln of 1 plus y squared. Then ln x will be minus ln x will be equal to c. And again, so we do not want a fraction, okay, so or a numerical coefficient which is a fraction, so thus we multiply everything by 2. So giving us ln of, so 1/2 times 2 is 1, so ln 1 plus y squared. And then 2 times ln x, that would be minus 2 ln x is equals to c times 2. So a constant, multiplied it with another constant, it would still be a constant. Okay, so we're not writing 2c. Okay, so for simplicity, although we can write 2c, but for simplicity, a constant multiplied to another constant is still a constant c. And then we apply rules of logarithm. So this one, so ln of 1 plus y squared, then minus, so 2 can be transferred into ln of x squared. Okay, so we move up the numerical coefficient 2, okay, so to become an exponent of x, so which is equals to c. And another properties of logarithm, so if we have difference of two logarithmic functions, then we just divide. So ln then, so we'll have 1 plus y squared, then divide it with x squared. So minus, so will become division, and then it will be equal to c. And then next we have we exponentiate. Okay, so we exponentiate both sides so as to remove the natural logarithmic function. So e raised to ln, so that will become 1. Okay, so that will leave us 1 plus y squared all over x squared. Then e raised to c. Okay, so e raised to c, so e raised to any constant, it's still a constant. So thus that will make it c. Okay, so if we do not want a fraction or a rational functions, okay, so that will become 1 plus y squared will be equal to c x squared. So we transpose x squared to the right hand side, and thus giving us for the final answer, so to be 1 plus y squared is equal to c x squared. And that is our first example. Okay, so you may pause the video if you want to go back, but then since this is a recording, I'll proceed with example number 2. Okay, so the first one is an example so which uses the formula for natural logarithm. So the second one, okay, so this is similar with our example for separable equation. So we're just going to do, okay, so I'm just going to rewrite this first as dy over dx then equals to x. Then I can separate the two as e raised to y. The other one would be multiplied with e raised to negative x squared. And then we multiply everything by dx, and thus leaving us to have dy is equals to x e raised to y e raised to negative x squared dx. But then there's still a y function at the right hand side, so we remove that. So we multiplied it with its reciprocal. The reciprocal of e raised to y is e raised to negative y. Right? So 1 over e raised to y, or that's the same as e raised to negative y. Then we multiply e raised to negative y dy is equals to x e raised to negative x squared dx. So So as we can see now, y is at the left hand side of the equation and x is at the right hand side of the equation. And we can see here that the functions, okay, the function of y and the function of x comprises of an exponential function. And we can integrate this one by simply employing, okay, so the formula for an exponential function, so such that the integral of EU du is the same as EU plus C. So EU du is equals to EU plus C. But then, for e negative y dy, our u is negative y, our du will be negative dy. But we only have dy, so therefore we need the neutralizing factor. So we are in excess of a negative number, so our neutralizing factor is negative 1. And then for the other one, so our u is negative x squared. Okay, so the exponent for e raised to negative x squared. And then our du, so derivative of this is negative 2 so negative 2x dx. So what we can see here, so we only have x and dx, so this is x and dx, so we are in excess of negative 2. And thus we have a neutralizing factor of negative 1/2. Okay, so as the reciprocal of negative 2. So negative 1/2. And we can now integrate the left hand side as well as the right hand side. So our formula is EU du is equals to EU plus C. So our e negative y dy, so we start with the neutralizing factor of negative, and then it's just EU. Our u is negative y, and is equals to, our neutralizing factor is negative 1/2, and then e, our u is this one, so which is negative x squared, then plus C. So we can move out. Okay, so we transpose this as 1/2 e raised to negative x squared and minus e raised to negative y is equals to C. So if we want to remove, okay, so the 1/2, so we multiply everything by 2, so giving us e raised to negative x squared, so minus 2 e raised to negative y is equals to C times 2. That would still be a constant. So the answer is e raised to negative x squared minus 2 e raised to negative y is equal to C. So this time around, so what we use is an exponential function. Okay, so the integral for an exponential function. So again, most of the separable equations are direct to the point. We just need to recall, okay, so the methods of integration. So this is our second example. So for the third example, so we have x squared dx plus y x minus 1 dy is equal to 0. Okay, so there are cases, so similar to this, so wherein dx and dy are separated by plus or minus. Okay, so this one. Okay. So it is separated by plus. Okay, so if that is the case, okay, so there's no need. Okay, so there's no need to transfer everything to the left, transfer everything to the y. Okay, so as long as the differential dx is multiplied it with x squared, okay, and the differential dy is multiplied it with y. Okay? But then what can we see here? So at the left at x squared, the differential dx, so this is multiplied with x squared. Okay? So in this case, so this entire function involves only a variable x, or a variable x, okay, is multiplied it with dx. But then for the differential dy, okay, so for the differential dy, okay, so we have a variable y multiplied to it. But the problem is this one. So we have an in excess of x minus 1. But then, so since this is a product of y and x minus 1, so I can just simply multiply entire thing, okay, so by the reciprocal of x minus 1. So that is 1 over x minus 1. And doing so that would give us x squared all over x minus 1 dx, then plus y, so x minus 1 will be cancelled out, so dy is equal to 0. As you can see here, so x and y are both at the left hand side of the equation, but then both are separated by addition, okay, by an operation, so which is an addition. So as long as dx and dy are separated by sum or difference, so those are still considered as a separable equation. So remember, for our first definition, so the function of x multiplied with dx plus or minus the function of y multiplied it with dy. So if it resembles that given format, then that is still a separable equation. So since we were able to separate x and y, so we integrate. Okay, so in this case, y dy can be integrated by power rule. Okay, so then we need to recall the power rule, that if we have the integral of u raised to n du, so that would give us u raised to n plus 1 over n plus 1 plus c. Okay, but then the x squared over x minus 1, so this is a rational function, but it is an improper fraction. Okay, so this is an improper fraction. So since the degree of the numerator is higher than the degree of the denominator, we cannot use logarithm here, because if we derive x minus 1, its derivative, it's dx. At the numerator, it's x squared. Okay, so we were not able to get the derivative, or we were not able to get the numerator after deriving the denominator. Thus, logarithm or natural logarithm is not applicable. But then again, so for rational fractions or rational functions who are improper in nature, so we divide. Okay, so we make it proper first. So we can do long division here. So x squared, then divide it with x minus 1. So x squared divides x is x. So x times x is x squared. And then we multiplied x with negative 1. So x times negative 1, it's negative x. So we divide, so x squared, we divide it with the first term of x. So the quotient will be x, and then the quotient is multiplied it with x minus 1. So that would make it x times x, which is x squared, x minus 1, which is negative x. And then we subtract. So subtracting the two, so we subtract everything. So this would make it x squared minus x squared. Okay, x squared minus x squared, that would make it 0. And then negative times negative x, so that would make it positive x. So we bring down x then, or it's just the same as 0 minus negative x, that would be positive x. And then we repeat, since x still have the same degree, or has the same degree as the x minus 1. So we divide, so x divides x, that would be positive 1. And then positive 1 is multiplied it with x minus 1. So 1 times x minus 1 would still be x minus 1. And then we subtract. So x minus x is 0, and negative or 0 minus negative 1 will be positive 1. And rewriting here, so our quotient is x plus 1. Then we have a remainder. Okay, so the remainder is 1. So plus 1 over x minus 1. Okay, so x squared over x minus 1, that is the same as x plus 1 plus 1 all over x minus 1. And thus, we rewrite the x squared over x minus 1, that is the same as x plus 1 plus 1 over x minus 1, then multiplied it with dx. Then plus y dy is equals to 0. So in here, so we can now integrate everything. So this is power rule, but then dx over x minus 1. So remember, our u here is x minus 1. Our du, which is dx, so which is the numerator. And thus that is a natural logarithm. So integral of x, so we use the power rule. So x raised to 1, that would be x squared all over 2. And plus integral of x, that is x. And then plus, so this one is ln of x minus 1. Then plus y squared all over 2 is equals to c. So we don't want a fraction for the numerical coefficient. So we multiply everything by 2. So giving us an x squared. So plus, so 2 times x is 2x. Plus 2 ln of x minus 1. And plus, so 2 and 2 will be cancelled out. So y squared. So c times 2, c will absorb the 2. So that would just still be a c. So we can have an answer so similar to this, or we can apply the properties of logarithm. So this is the same as ln of x minus 1 squared plus y squared is equals to c. So whichever of the two, so that will be the final answer. Okay, so far we have 3 examples. So one utilizes natural logarithm, the other utilizes exponential function. This one so uses power rule, okay, and additional techniques. Okay, so for improper fraction, so we need to perform the operation first. So how about the fourth one? So what formula, okay, so are we going to use for this one? So again, so it's on the format of sum of a function multiplied with dx plus a function of x and y multiplied it with dy. So again, so anything so which is okay, so any variable, okay, so other than the differential, so we remove it. So dx is multiplied it with xy cubed, so we are in excess of y cubed, so we remove it, so y cubed. And then for the differential dy, so this is okay, so y plus 1, but then we have e raised to negative x. So its reciprocal is positive, e raised to positive x. So that's giving us, so y cubed will be cancelled out. So we have x e raised to x dx. X e raised to x dx. And then for y, so we have plus, so y plus 1 all over y cubed. So e raised to negative x times e raised to x, that will be e raised to 0, which is 1. Then the whole thing is multiplied it with dy is equals to 0. Okay. So what is good? So we were now able to separate x from y. Okay, so the first term, x ex dx, is all function of x. And then the second term is all functions or all function of y. But how do we integrate? So we have product of algebraic and exponential. Right. So the easiest way to do that one is through tabular method. Okay, so we use tabular method. Okay, so for x and ex. So remember, in tabular method, so we derive the algebraic function and then we integrate the other function. Okay, so as long as one of the function is algebraic, so usually the most convenient way is to use tabular method. But if we are more familiar with integration by parts, then we can try to do so. So x, so we derive, so derivative of x, it's 1. Then derivative of 1, it's 0. So while the integral of e raised to x, it's still e raised to x. And then integral of e raised to x, it's still e raised to x. And then, so we attach the sign. So alternate sign, so this positive, negative, positive. Then this is multiplied diagonally. So that's the integral of x ex dx. So we'll start with this. So positive x, then multiply it with e raised to x. Then minus, so 1, then multiplied it with x. So that would be x ex minus e raised to x. But then we have y plus 1 all over y cubed. Okay, so the numerator or the degree of the denominator is higher than the numerator. The degree of the denominator is higher than the numerator. It is a proper fraction. But then we cannot use logarithm, because once we derive y cubed, that will be 3y squared. 3y squared. What we have at the numerator, it's just y. Okay, so kulang tayo ng power. So if that is the case, so since there's only one term at the denominator, so this one can be separated as y all over y cubed. Then the other one is plus 1 over y cubed dy is equals to 0. So we can simplify that further. So y over y cubed, that would be y raised to 1 minus 3, that is negative 2. So y raised to negative 2, and then plus y raised to, so we just simply put it up, so dy is equals to 0. So now we can now integrate. Okay, so integral of x ex dx, so using tabular method, so that is x e raised to x minus e raised to x. And then for y raised to negative 2, so we use power rule, y raised to negative 2 dy, that would be, so plus y raised to negative 2 plus 1, it's negative 1. Then over negative 1. Then plus y raised to negative 3 plus 1, that would be negative 2 all over negative 2. Is equals to C. Okay. So we want to multiply everything by 2. So giving us 2x ex minus 2 e raised to x And I'll have minus 2y raised to negative 1. And then minus y raised to negative 2 is equals to c. And then if we want to remove all the negative exponents, so we can multiply everything by y squared. So giving us 2x y squared e raised to x minus 2y squared e raised to x minus 2 y negative 1 plus 2, that is just 2y, and minus y squared and y raised to negative 2, that would be y raised to 0, so which is 1, is equals to c. So this time around, so we multiply a variable with a constant. So constant, okay, does not absorb variable, so thus this will be c y squared. So that will become our final answer. 2x y squared e raised to x minus 2y squared e raised to x minus 2y minus 1 is equals to cy squared. So that is our fourth example. So this time around, so we use a new method. Okay, so this is to review. So we use tabular method, or again, if we're more familiar with integration by parts, so we do integration by parts. And then this is another approach. Okay, so for rational function, if we can perform the operation or simplify a given rational function, so try to simplify it first. Okay, so this time around, okay, we are given a trigo function. Okay, so for our differential equation, so most probably, so we will be using some integrals of trigo function. So in solving these, okay, so what is in excess here? So looking at the fifth example is the cosine cube x dy. So we will be multiplying everything then. So by 1 over cosecant cube x. So doing so, so we'll have 1 over cosecant cube x, then dx, then minus tangent squared y dy is equal to 0. But then remember that 1 over cosecant, okay, is an identity. So 1 over cosecant is sine. Okay? So 1 over cosecant x is sine x. So the inverse of cosecant is sine. So thus, we can write this one, but it has a power of 3. So that would make it sine cube x dx. Then minus tangent squared y dy is equals to 0. So in here, so what kind of equation is this? So this is a trigo differential equation, but then we have sine cube and tangent squared y. So we don't have a direct integral of sine cube, and at the same time we don't have a direct integral of tangent squared y. So we need to transform. Okay, so we need to transform the given equation. Okay, so sine cube, so we have an odd exponent. So what we will do here is we separate them into 2. So I'll do a sine squared x and a product of sine x dx. So we separate it as sine squared and sine x. And then for tangent squared, so we don't have an integral for tangent squared, but then there is an identity. So for tangent squared y, so tangent squared y plus 1 is actually equal to secant squared y. So thus, tangent squared y is equals to secant squared y minus 1. So giving us minus then secant squared y minus 1 dy is equals to 0. So sine squared x times sine x cannot be integrated again. But remember the Pythagorean identity, that is cosine squared x plus sine squared x is equals to 1. So thus, sine squared x is equals to 1 minus cosine squared x. So we can further rewrite this one as 1 minus cosine squared x, multiplied it with sine x dx, then minus secant squared y minus 1 dy is equals to 0. So in here, so we can distribute now. So we distribute 1 with this one. So I'll have sine x dx, then cosine squared, so I'll have minus cosine squared x sine x dx, and I'll have the negative here, so negative secant squared y dy, then negative and negative, so that would be plus dy is equal to 0. So can we integrate all of these? So we can. So remember the integral of sine x dx, that is negative cosine x plus c. So for secant squared, so we have the secant squared x dx. So the integral would be tangent, it should be y. Tangent y plus c. And of course, we have the integral of dy, which is y. But then, for this, so since this is a product of a cosine squared and a sine x, so we can let our u here, so to be the base of the term with the power of 2, so which is cosine. So once we derive cosine, so that would be a negative sine x dx. So as you can see here, so this is just a power rule. So we have the base of a cosine x, and then the derivative is the negative sine x dx. And thus we can use right away the power rule there. So integral of sine x will be negative cosine x. And then, so this one will become, so since the differential u is negative sine x, so which is the same as what was on the given, so therefore this would become plus cosine cube x all over 3. Okay, so power rule. Next one is just a trigo. So secant is negative tangent y, then plus y is equals to c. So we can multiply everything by 3. So giving us, I want to start with a positive, so I'll start with y. So 3y, and then minus 3 tangent y. Then I'll have the x, so minus 3 cosine x. Then plus, so 3 would be cancelled out. So cosine cube x is equals to c. So we have 3y minus 3 tangent y minus 3 cosine x and plus cosine cube x. Okay. So that is our fifth example. So it involves trigo substitution, okay? Or sorry, trigo transformation. So it involves trigo transformation. So we have another example. So this time around, so we are given an initial value problem. So when I say initial value problem, so I'm referring to we are given an initial condition. So whenever we are given an initial condition, so the problem is asking for a specific solution, okay, or a particular solution, so rather than a general solution. So general solution involves arbitrary constant c. Okay, but for IVP, okay, or initial value problem, so we get what's the value of c, and then we substitute it so to get a particular solution. Okay, so for this given example, so we are given 1 minus y squared, so dx, and minus the integral of 1 minus x squared dy is equals to 0. So we multiply everything, so in excess. So for dx, so we are in excess of square root of 1 minus y squared. And similarly for dy, we are in excess of 1 minus x squared. And making it to be dx over the integral of 1 minus x squared, then minus, so dy over the integral of 1 minus y squared is equal to 0. So this resembles, so we have the square root of 1 minus x squared. So it's either we're going to use a trigo substitution, algebraic substitution, but then it has the format of inverse trigo. So we're in our a squared will be 1, and then our u squared will be x squared. So a is 1, so u is x. So derivative of u, it's dx. So which wherein we get the numerator. Okay, the square root of 1 minus x squared. So u squared is x squared. U is x, so du is dx. So therefore, we use the formula. So what is our formula? So for du over the square root of 1 minus u squared, that is arc sine of u over a plus c. Or in short, so this would be arc sine, our u it's x, our a is 1, or that is just arc sine of x, and minus arc sine of y is equal to c. So now that we have the general solution, so we find the particular solution. So when it says y of 0 is equals to the square root of 3 all over 2, that means when x is 0, y is square root of 3 all over 2. So we substitute. So this is arc sine x is 0 minus arc sine of square root of 3 all over 2 is equals to C. So arc sine of 0 is 0. So arc sine of square root of 3 all over 2. So if we make this one in the degree mode, so C here, okay, so in degree mode, so C here will be negative 60 degrees. Okay, so in degree mode. But then, if we want to make it in radian mode, okay, so we can use here arc sine square root of 3 all over 2. So what we will be getting there is 1 point something. Okay, so in decimal form. But then, so I'm just going to, as long as it is a trigo equation, so our values so should be in radian. Okay, so that's why we cannot write 60 degrees there. So we multiply this one with pi all over 180 degrees. So that makes it a negative pi all over 3. So giving us a C to be equivalent to negative pi all over 3. So we substitute it with the original equation then. So arc sine of x minus arc sine of y is equals to negative pi all over 3. We transform it or transpose it to the left hand side. So that would make it plus pi all over 3 is equals to 0. And that is example number 6. Okay, so that's how we solve initial value problem. So we substitute the initial value so to get the value of C, and then later on we substitute the C, okay, or the value with the arbitrary constant of the general solution. So to get the particular solution, so without the arbitrary constant. So let's have our last example. Again, so example number 6, so we recall inverse trigo. Okay, so we recall inverse trigo. So you can see on the given examples, so we were able to recall so majority of the different integration techniques that we had covered so in integral calculus. So next we have dy over dx, and it is equal to y squared minus 1 all over x squared minus 1. So in here, okay, so we can make y the left hand side and then x at the right hand side. So we multiply it with dx and then y squared minus 1. So giving us dy over y squared minus 1 is equals to dx over x squared minus 1. Okay, so again, so this is an example. So we're in, this is not a natural logarithm. Okay, so there, although there's an operation involved, so we cannot simplify it further so as to use other method. The only way on solving this particular problem is to use partial fraction. Okay, so since the left hand side is exactly the same as the right hand side, it's just a difference of variable used. So I'll be using the variable x. So I'm going to remove the differential dx. So I just need to get 1 over x squared minus 1. But then x squared minus 1 is factorable. Okay, so its factor is, so we can make this one as dy all over, so y minus 1 and y plus 1. So similarly, so I'll have dx over x minus 1 and x plus 1. So thus, it's Equivalent partial fraction then, so will be x minus 1, then plus x plus 1. Since this is linear, so this is A, this is B. So we multiply everything by x squared minus 1, or the product of it is x minus 1 and x plus 1. So x squared minus 1, so will be cancelled out, so leaving us 1. Then A, x minus 1 will be cancelled out, so giving us x plus 1. Then plus B, x plus 1 will be cancelled out, leaving us x minus 1. So the easiest way is the assumption for the values of x. So we want to get the value of A. So to get the value of A, we need to zero out, okay, so the coefficient of B. So that is when x is 1. So that would be 1 is equals to A. So 1 plus 1 will be 2. And then 1 minus 1 would be 0. So thus B will be 0. So therefore A will be equal to 1/2. And then, so we need to get the value of B. So we zero out A. So we assume that x is negative 1. So this is 1. So negative 1 plus 1 is 0. So canceling it out A. Then B. So negative 1 and negative 1, that's negative 2. Thus A or B is negative 1/2. So therefore, 1 over x squared minus 1, it's the same as 1/2 x minus 1, then minus 1/2 x plus 1. So we change dy over y minus 1 times y plus 1 to its equivalent. It's actually the same, so we just change x to y. So dy, then so will be 1/2 over y minus 1, then minus 1/2 over y plus 1. Then equals 1/2 over x minus 1 minus 1/2 over x plus 1. Then of course, plus c. Or sorry, we haven't integrated it yet. So we remove it first. Okay. So we integrate it now. So the integral of this will be 1/2. So ln of y minus 1 and minus 1/2 ln of y plus 1 is equals to 1/2 ln of x minus 1 and then minus 1/2 ln of x plus 1 plus c. So we multiply everything by 2. So leaving us to have ln y minus 1 minus ln of y plus 1 is equals to ln of x minus 1 minus ln of x plus 1 then plus c. So we combined all ln's. Or we combine the two, so this one would become ln of y minus 1 all over y plus 1. And it's equals to, this is the same as ln of x minus 1 all over x plus 1 plus c. Then we move it out to the left, so ln of y minus 1 over y plus 1 and then minus ln of x minus 1 over x plus 1 and it's equals to c. So this one will become ln of y minus 1 all over y plus 1 and then divide it with x minus 1 all over x plus 1 is equals to c. and we exponentiate both sides. So that would give us y minus 1 all over y plus 1 all over x minus 1 over x plus 1 is equals to c. And we can make these as y minus 1, so times x plus 1 all over, so the extremes, and then the means will be the denominator, y plus 1 all over x minus 1 is equals to c. And this is another IVP problem, that is when x is 0 or when x is 2, so y is 2. So we substitute, so 2 minus 1 and 2 plus 1 all over 2 plus 1 over 2 minus 1. Actually, 2 minus 1, 2 minus 1, 2 plus 1, 2 plus 1. So therefore, c is equals to 1. And therefore, our final answer then so would be y minus 1 all over, or multiplied it with x plus 1, and y plus 1, x minus 1 is equals to 1. Simply put, so y minus 1 times x plus 1 is equals to y plus 1, x minus 1. And that will be the final answer. And this one so uses partial fractions. And again, we were able to have some review of all, majority, not all, but majority of the integration techniques that we have in calculus. Okay, so you may now proceed with activity number, or Canvas assignment number 2, so to check your understanding about separable equations. And that's it. Good day.